slowing down. If you increase the gravity expansion, that's basic physics.
There's some steam here, huh? Would I dare to take this glove away? Yeah, easy. Easy bitty, man. No problem. Hot or cold? Begin with a C. It's cool. What does that steam do? Begin with a X. Expand. And when it expands, what's it do? Begin with another C. Cool. And there's your evidence of it right there. Isn't that remarkable?
Now, the sun's corona is tremendously hotter than the actual surface of the sun. Now, if on the surface of the sun, and this has been a conundrum that scientists have been trying to figure out for a long time, and they came out with some arbitrary ideas like, oh, it's tornadoes on the surface of the sun, that's why the corona gets hot. Or like, oh, it's magnetic field arcing and creating a big spark, and that extra spark adds energy to the whole corona, and that's why the corona is like 100,000 degrees while the surface is 100,000 degrees Kelvin, while the surface is like literally 6,000 degrees Kelvin, which makes no sense.
The mystical seeming quality of heat
There's
is
nothing
more than
about
the motion of a
physics
substance
that makes
compared to
sense.
particles. Temperature is just a measure of internal kinetic energy.
But if you understand that as matter pressurizes, it actually slows down. Its time slows down. As its time slows down, it literally cools down.
They get colder and colder and denser and
That's
denser.
And so as that matter leaves the surface of the sun, its time is able to increase. As its time is able to increase, all the components within the atom and within the nucleus of the different subatomic particles, they're all able to start moving much, much faster. As their time is increasing, their energy potential increases and they heat up.
Right.
That's why as matter leaves the surface of the sun, it literally gets hotter, which defies the laws of physics as we know them here on Earth. Okay? And that's a major point that mainstream science hasn't quite accounted for in their equations. And right now they think the sun stars are big balls of gas with gravity pushing, holding the ball of gas together while the heat from within the star is pushing it and resisting the force of gravity. This is completely nonsense.
It's a big computer.
Stars are not giant balls of gas. They're giant crystal core quantum computers, okay, also called singularities. When you look at a black hole, what does mainstream science call a black hole? They call that a singularity, okay?
Right, we are the
When I
singularity.
call all of the cores of the cosmos naturally occurring crystal core quantum computers, that's because at their core is a singularity. Now, another thing I want to mention is that all of mainstream science and computer science and also advanced physics labs and quantum labs, they're trying to create extremely advanced computers, quantum computers. They're trying to create extremely advanced quantum computers. And what have they coined the name for those extremely advanced quantum computers? They've coined the name singularity. So literally a crystal core quantum computer, which are the cores of the cosmos, I've been coining them naturally occurring crystal core quantum computers, and mainstream science calls those singularities, okay? And then if you actually think about a quantum computer that they're trying to build in laboratories, and they're trying to call those singularities, when the quantum computer is intelligent enough that it is able to achieve computer supremacy and also possibly have intelligent self-awareness and other kind of intelligences that wouldn't normally be equated with computers, they call that a singularity. So they're calling the two different things the same thing because they are the same thing. They're literally the same thing. Okay, so the point being, as you compress matter, as you get closer and closer to the center of mass, your time reduces. As your time reduces, your temperature reduces. Okay, and if you know anything about quantum mechanics, when you try to create a quantum computer, you're trying to get the actual components that are called the qubits. You're trying to get them to as close to absolute zero as possible.
Matter can exist in various states. Atoms at high temperature always form gases. If you cool the gas, it becomes a liquid. If you cool the liquid, it becomes a solid. But under certain circumstances, if you cool atoms far enough to extremely low temperatures,
This is why we're
they undergo
everywhere.
a very strange
at the end of
transformation.
time.
Ultra-cold atoms will be used to process information.
When you go to low temperatures, the quantum mechanical
That's why
properties
every
of the
single
atom
one of us
become
are
important.
nodes in the computer.
These are very strange, very unfamiliar to us, but in fact, each one of these atoms starts to display wave-like properties. So instead of points like that, you have little wave packets like that moving around. It's really difficult for me to explain just why that is, but that's the way it is. Now, as you go to very low temperatures, the size of these packets gets longer and longer and longer. And then suddenly, if you get them cold enough, they start overlapping. And when they overlap, the system behaves not like individual particles, but particles which have lost their identity. They all think they're everywhere. This little wave packet over here,
so who are you?
Can't tell whether it's this one or that one or that one or that one or that one or that.
You're
It's
everywhere.
there and it's there. They're all in
are
one
everywhere.
great big quantum state. They're all overlapping. They're all doing the same thing.
And that right there
And what
is
they're doing, to a good approximation, is
the
they're
big
simply
ball of
sitting at
energy
rest.
the Maya talked
This
about.
Bose-Einstein
So that's
condensate
where
is
I've
very
lost
difficult
right now.
to imagine or to visualize. I can imagine what it's like to be an atom running around gaily, freely, bouncing into things, sometimes going fast, sometimes going slow. But on the Bose condensate, I'm everywhere at once. I've lost my identity. I don't know who I am anymore.
Right.
I'm at rest, and all the other atoms around at rest, but they're not other atoms around. We're all just one great big quantum system.
Right.
There's nothing else like that in physics.
And isn't it interesting that Mother Earth does the exact same thing? As you get closer and closer to the center of the
one.
mass of the celestial object, time literally slows down and the temperature decreases. That's the main omission that mainstream science right now is saying, is that as you get closer and closer to the center of a star, it gets hotter and hotter. It's the exact opposite. Because there's a reduction in time, if you reduce an atom's time, you're literally slowing it down. As you're slowing it down, you're reducing literally what the definition of temperature is: movement.
When the stream of light particles from the laser hits the selected atoms in the gas cloud, the atoms slow down and hence become cold.
So if you have, say, for example, a round ball of iron, and it's, say, 100 degrees Fahrenheit, there's so much motion within the atoms that dictate that that is, quote-unquote, the temperature, okay? If you're to take that same ball of iron and get it to as close to 0 degrees Kelvin as possible, which is absolute zero, there will be a lot less motion within that ball of iron, okay? Temperature and the rate of time are direct, and the speed of light and gravity are all tied to each other. If you get a ball of iron as close to absolute zero as possible, the actual subatomic particles within the atom, within that iron ball, will start slowing down. If you increase the gravity to a point where it gets close to absolute zero, the same effect happens.
Dan Kleppner's idea was to cool the hydrogen atoms by making use of their magnetic poles. He used a strong magnetic field to create a cluster of atoms in a cold trap.
So at the cores of the cosmos is literally almost 0 degrees Kelvin, okay? There's no time and there's no heat. And that's the properties that you're looking for when you're trying to create a quantum computer.
And the most massive black holes in the universe, the supermassive black holes with millions of times the mass of the sun, will have a temperature of 1.4 times 10 to the negative 14 Kelvin. That's low. Almost absolute zero, but not quite.
How interesting is it that the center of a black hole, okay, which is basically the center of the cores of the cosmos, is called, quote unquote, the singularity, okay, which I call naturally occurring crystal core quantum computers, and quantum mechanics and scientists who are working on quantum computers here on Earth, who are trying to cool down matter to absolute zero so that they can build quantum computers that they will then call the singularity. Isn't that interesting how there's a correlation between the two? I mean, I can't make this stuff up. Google it for yourself.
Right.
That is the paper. That's the way I wrote it. I'm going to be coming out with a lot more videos. I hope you like this type of content. If you have any questions, put them in the comments below. I'm going to be converting a lot of my articles into video articles, and I'm going to be coming out with a lot more content like this. So if you don't want to miss any of it, go ahead and feel free to subscribe, and stay tuned because I'll have a lot more content coming to you shortly.
Your brain wired into a what? A set of images.